Hello, I am Dr. Santosh Kumar, now Mechanical Engineering Department, SCM Professor. Now I am going to discuss about the course Fluid Mechanics and Fluid Machines. In this course, there are two parts, Fluid Mechanics and the Fluid Machines. I am going to discuss now today about the Fluid Mechanics. The module first is Introduction to Fluid Mechanics. Introduction to Fluid Mechanics. First, there are two words, fluid and mechanics. The first, we have to discuss about the mechanics. What is the mechanics? Mechanics is the oldest physical science that deals with the behavior of forces in both a stationary and moving body under the influences of forces. The branch of mechanics that deals with the body at rest is known as fluid statics, while the branch of that deals with the body in motion is called the dynamics. First, what is the fluid mechanics? The fluid mechanics is defined as the science that deals with the behavior of fluid at rest or in motion. The study of fluid at rest is called fluid statics, while the study of fluid in motion, where pressure force are not considered, is called fluid kinematics, and if the pressure force is considered, then it is known as fluid dynamics. First, what is fluid? Any substances which can flow is known as fluid. Then first, what is the substances? The substances which have definite mass, finite mass, occupying some space and tangible. And first is, what is flow? When the relative changes of position of particle with respect to the time, then this is known as the flow. The fluid having some characteristics like having some mass, and fluid does not have any certain shape. The shape of the fluid is like the vessels. When we can fluid is kept in the cylindrical vessel, then the shape of the fluid is cylinder. When we contain or kept in the rectangular vessels, then it is shaped as rectangle. The distinction between a solid and a fluid is made on the basis of substance's ability to resistance the applied shear or tangential stress that tends to change its shape. A solid can resist an applied shear stress by deforming, whereas a fluid deforms continuously under the influence of shear stresses, no matter how the shear stress is small. In solid, a stress is proportional to a strain, but in case of fluid, the stress is proportional to the rate of shear strain. What is the fluid? When a constant shear force is applied, a solid eventually stops deforming at some fixed strain angle, whereas a fluid never stops deforming and approaches a certain rate of strain. In this case, in first diagram, the solid body deform at an angle of alpha. But in case of fluid, when we apply the tangential force, the initial state of the fluid is T0. When some forces, tangential force is applied, then it is deformed with after time T. The first dotted line is the fluid particles. After time T2, this is the fluid particle. That means fluid is continuously deforms when it is applied to a shear stress. The C, in this case, in a liquid, molecules can move relative to each other, but the volume remains relatively constant because of the strong cohesive force between the molecules in the liquid. As a result, liquid takes the shape of the container it is in, and it forms a free surface in a large container in a gravitational field. But in case of gases, there are no free surface. On the other hand, gases expand until it encounters the wall of the container and fills the entire available space. This is because the gas molecules are widely spaced and the cohesive force between the gas molecules are very small. Unlike liquid, gases cannot form a free surface. Thus, see, in this case, the liquid, this is the freest surface, but in case of gases, the gases molecules are spread over the entire surfaces. There is no free surface in the gas molecules. Now I am going to discuss about the properties of the fluid. First property is density or mass density. Density or mass density of a fluid is defined as the ratio of mass of the fluid to its volume. Thus, the mass per unit volume of the fluid is called density, and it is denoted by the rho. The unit of mass density in SI unit is kg per meter cube. And the density of liquid may be considered as constant, while that of the gases changes with the variation of pressure and the temperature. When we define mathematically the mass density, then the rho is equal to mass of the fluid to volume of the fluid. The volume of fluid of water is 1 gram per centimeter cube or 1000 kg per meter cube. The density of the substances in general depends on the temperature and the pressure. And in most of the cases, the density of gases is proportional to the pressure and inversely proportional to the temperature. Liquid and solids, on the other hand, are essentially incompressible substances, and the variation of the density with pressure is usually negligible. There is no change in density when pressure and temperature are varied. Second property is a specific weight or weight density. The specific weight of the fluid is the ratio between the weight of the fluid to its volume. Thus, the weight per unit volume of the fluid is called density, weight density, and it is denoted by the symbol W. Mathematically, the weight of a specific weight is the ratio of weight of the fluid to volume of the fluid. Now, it can also written as weight of the fluid is mass of the fluid into acceleration due to gravity divided by volume of the fluid, and it is also equal to mass of the fluid into g. G is the acceleration due to gravity and volume of the fluid. Now, ratio of mass of the fluid to volume of the fluid is known as the density, that means rho, and acceleration due to gravity g. Now it is finally W is equal to rho into g. You can calculate the specific weight when density is of the liquid or gases is given. Third one is a specific volume. A specific volume of the fluid is defined as the volume of the fluid occupied by unit mass, or volume per unit mass of the fluid is called a specific volume. Mathematically, it is a specific volume is equal to volume of the fluid to mass of the fluid is equal to 1 divided by, you can change it, mass of the fluid divided by volume. Now it is equal to 1 by rho. That means a specific volume is the reciprocal of the, or inversely proportional to the density of the fluid. Thus, the specific volume is reciprocal of the mass density, and it is expressed as meter cube per kg, and it is commonly applied to gases, not fluid. A specific gravity. A specific gravity is defined as the ratio of weight density or density of the fluid to weight density or density of the standard fluid. What is the standard fluid in case of fluid? In case of liquid, water is considered as a standard fluid, and in case of gases, air is considered as the standard gas, a standard fluid. For liquid, the standard fluid is taken as water, and for gases, a standard fluid is taken as air. Now, mathematically, it is denoted by and specifically gravity is denoted by the letter S. And for liquid, when you calculate the specific gravity, then a specific gravity is equal to weight density of liquid to ratio of weight density of liquid to weight density of water. And for gases, it is the ratio of weight density of gas to weight density of air. And it is also the weight density of liquid. Now you can calculate the density of liquid from the multiplication of a specific gravity and weight density of water. That means a specific gravity of liquid is S into 1000 into 9.81 Newton per meter cube. A specific gravity. It is a specific gravity of a fluid is known. Then you can calculate the density of the fluid will be equal to the specific gravity of the fluid multiplied by the density of water. For example, the specific gravity of mercury is 13.6. Hence, density of mercury is equal to 13.6 multiplied by the density of water, which is 1000 kg per meter cube. And finally, the specific gravity of the mercury is 13,600 kg per meter cube. This is the typical value of, these are the typical value of a specific gravity for some fluids. Water has a specific gravity 1, blood 1.04. Then air is 0.0013 at 1 atm pressure. Now there are some numerical problems. First one is calculate the specific weight, density and a specific gravity of 1 liter of liquid which weight is 7 Newton. Now volume, the given data is volume is equal to 1 liter. You can write down it 1 by 1000 meter cube, and weight of the liquid is given as 7 Newton. Now you can calculate the specific weight, which is equal to the weight to ratio of weight to volume. Weight is given as 7 Newton and volume is equal to 1 by 1000 meter cube, which is equal to, after the simplification, it is equal to 7000 Newton per meter cube. Now density, you know that the density is equal to W divided by G, and W we already calculated the 7000 and G is 9.81. After the simplification, density is equal to 713.5 kg per meter cube. Now a specific gravity, which is equal to the density of liquid to density of water, and density of liquid we have already calculated the 713.5 and density of water is 1000. Then after the simplification, it is 0.7135, which is dimensionless. Now second problem is calculate the density, a specific weight and weight of 1 liter of petrol of a specific gravity is equal to 0.7. Now volume of 1 liter is equal to, you can write 1 into 1000 centimeter cube, and which is also equal to 0.001 meter cube, and a specific gravity of the petrol is given at 0.7. Now you can calculate the density. Density is equal to a specific gravity into density of the water, which is 1000 kg per meter cube. and is equal to a specific gravity S is given at 0.7 and multiplied by 1000 is equal to 700 kg per meter cube. And second one is a specific weight which is equal to rho into G. Now put the value of rho which is equal to 700 and G is 9.81. After the simplification it is equal to 6867 Newton per meter cube. And third one is weight. We know that the specific weight is equal to weight by volume. Now a specific weight is equal to weight divided by volume is 0.001 meter cube, or put the value of W, that means a specific weight which is equal to 6 and 6 7, and put the value after this simplification you can calculate the weight which is equal to 6.867 Newton. These two problems are based on the properties of the fluid. In next class, I will discuss the important properties of the fluid which is known as viscosity.